This is a screen capture video for Unit 5.4, continuing with muscle tissue. The purpose of muscle tissue is for movement, and when the muscle tissue contracts, it either moves itself and usually moves something else with it. It could be the body, it could be bones, it could be blood, liquid, or it could be material that is in the organ in which it's located. For instance, in the intestine, where there's a bolus of food that's moved along by peristalsis, the contraction of the muscles that moves the food along the digestive tract. When you're reading, or you may hear me use the terms interchangeably, cell is the same thing as fiber. So muscle cell, muscle fiber, same things. I've got three different types of muscle to talk about, and skeletal muscle is the first type. And I have an image that I pulled off the internet, and in this skeletal muscle you can see it. The fibers, it's a little bit hard to tell here where they end and begin, but they are multinucleated and they are heavily striated. Striation would be a stripe, and there are many stripes or striations to the muscle. If you were to take an anatomy physiology class and study muscle tissue and muscle contractions in greater depth, you'd learn about H bands, I bands, A bands, and actin and myosin filaments. And the actin and myosin filaments are interlocked, and they slide past one another. And when they slide past one another, that's what causes contraction of the muscle tissue. And it usually helps with illustrations to show that. I just mentioned that to you. There is calcium involved and a chemical called adenosine triphosphate, which provides the energy for that. They're also showing some capillaries here because muscle tissue would need blood flow, it would need oxygen and nutrients. And we know that when our muscles are especially active, we don't have enough oxygen, then we start to ferment, and there's a little bit of soreness that is associated with that. Skeletal muscle is also called striated muscle. In the past, it was known as voluntary muscle, but most anatomy physiology people and techs have gotten away from using voluntary because that doesn't describe it as well as striated muscle or skeletal muscle, and can cause some confusion. As I mentioned before, if there's no ATP, I mentioned that being needed, then the muscles will not move. They become locked in place, and that phenomenon is called rigor mortis. That's where there's stiffness upon death. And that's something that forensics experts have used in the past. It's not the only thing that they use, but they look at rigor mortis to determine how long a person's been dead. That is temperature dependent. And another story to illustrate this, and probably won't forget it. There was a man, a husband, out east on the East Coast. I don't recall which state he was in, but he decided to murder his wife, and he understood that the pathologist would consider rigor mortis in trying to determine when she died. So after he murdered her, he turned on the air conditioner in the bedroom, and it wasn't a real hot time of the year, and the air conditioning wasn't on in any other part of the house, but I think he had a window air conditioner, turned it on full blast, so that when her body was found, it was very cold in the room. And what he was wanting to do was to delay rigor mortis to put her time of death later than what she actually died. And he proceeded to go out and make some calls. He made a call from a friend's house. What he didn't realize, the daughter of his friend didn't like him, and when he was acting like he was talking to his wife, she picked up a phone in another room and listened, and there was nobody on the other line, and he was actually just acting like he was calling her, and really wasn't. He went out on the ocean with his friend sailing and acted like he was concerned, and had some people check on his wife because he couldn't get a hold of her. That's when they found her dead. But instead of just using rigor mortis, they used the digestion of the contents of her last meal. They inquired as to when she ate, and based on when she ate, they looked at how far along the digestion had occurred, and they were able to place the time of her death correctly. Before he left, he was eventually charged and convicted for her murder. One of the things that we noticed with the striated muscle, and I've already pointed this out, the striations are clearly visible, much more readily visible than the other types of muscle, and they're multinucleated. And the striated muscle generally attaches to the skeleton. It helps our skeleton move. Sometimes I give a cadaver history, especially to my face-to-face classes, with talking about muscle. You're talking about sards or sarco, and that has to do with flesh. That's what it means in the Greek. And so if you come across flesh in Greek translations, or sometimes the word carnal is used, that's the flesh, that's the muscle. That's what the gladiators, that's what the ancients saw when a person died or an animal died. It was the flesh. That's usually what they were after, is the muscle. And so the sarco or sards is the Greek term for that. It's interesting, the dealing with dead bodies is interesting historically. The Egyptians didn't have a problem with preserving dead bodies. They saw it as a part of their belief system that they prepared bodies for the afterlife. They even killed slaves to go along to serve royalty after the royals died, and would preserve them so that they mummified. They would dry faster without spoilage. The Romans weren't so open to dissecting bodies. The Jews weren't either. When a Jew touched a dead body, they were considered unclean for a certain number of days until they showed himself or herself to the priest, and they could be declared clean. The Romans, they had superstitions dealing with bodies. Some of the early anatomists are said to have pulled down bodies off of crosses and would dissect the body and then get rid of it as quickly as they could, especially before morning came. But they would do their dissections by candlelight and not be caught, not be seen. It was Roman law that if you were to take somebody down from a cross without authorization, then you yourself could be crucified. The Europeans did some dissections. They would do dissections of recently dead people, autopsies. This was done in a hospital where Ignaz Semmelweis worked, and he actually tried to talk the medical students into washing their hands after their dissections because they weren't doing it, and they were spreading Streptococcus pyogenes bacteria from dead women who had died from puerperal fever to women who were giving childbirth, and there was a very high death rate. In some cases, over half the women who were giving birth would eventually die from infection. He had them wash their hands in lime water, and he greatly reduced the infection rate and the death rate. I sometimes will mention an account given by Dr. Howe, who taught at the University of Illinois in the Anatomy and Physiology department, that he would recount. It had to do with how the English government came to provide dead bodies for the medical schools and universities. It happened that before the government stepped in and provided better means for providing bodies, that people would steal bodies. They were grave robbers. After somebody had been buried, they'd go out at night and dig up the body, and then they'd sell it to the medical school. And the story that Dr. Howe told was that that was hard work, and so a couple of guys eventually went from grave robbing to picking up prostitutes and killing them and providing their fresh bodies to the medical schools. And that was eventually discovered, as well as these two guys enticing people to their home to stay and then killing them and providing their bodies. They were eventually convicted. One turned state's evidence on the other, and one was executed. But after that, the English government decided to provide cadavers for the schools to cut down on the grave robbing and the murdering. The next type of muscle, it's a second type, is cardiac muscle. It's only found in the heart. It's the only place it's located. Its interesting characteristics are that the fibers are branched. You can see that in the illustration and in the image taken through a microscope. You do see some striations, but they're very light, much lighter than the striated muscle. The other thing you see are these dark lines, and those are intercalated discs. And those intercalated discs are for communication, fast communication from fiber to fiber. In the heart, the muscle needs to fire in a very rhythmic, organized fashion, and these intercalated discs do so that the blood is moved in one direction properly. And other muscle types don't have those intercalated discs. But those are a type of cell junction where chemicals are moved across quickly. The third type of muscle is smooth muscle, and it lacks striations. There are no striations in it, and you don't see the number of nuclei in the fibers that you do in striated muscle. You also notice that, I have down here, that smooth muscle contracts longer. That's one of the characteristics over striated muscle. Long contractions can occur, whereas in skeletal muscle, the contractions are shorter and the muscle becomes more easily fatigued. In the next unit, I'll talk about nervous tissue.